Hey guys, this is Thursday, April 9th. And yesterday we talked about homogeneous mixtures called solutions on page 467. So today we're going to complete the job with heterogeneous mixtures on page 465. Now, if you remember, I told you that mixtures have a varied composition, whether they're homogeneous or heterogeneous. Homo means alike, hetero means different. So homogeneous are alike everywhere throughout the solution. It's salt water over here, it's salt water over there, it spreads evenly throughout. It is alike. Now, mixtures are composed of two or more substances that can be separated by physical means. So if this is a homogeneous mixture, a solution, which it is, it's spread evenly throughout. How am I going to get the salt out of here separated from the water? If we can do it by physical means. If I don't have to have like electricity or some other chemical means of separating these two things. All right, well, here's how you do it. You simply heat it up. And if you heat it up, the water goes up, it vaporizes, but it's still H2O. It's H2O liquid that has become H2O vapor. And then these little salt crystals, they recrystallize. And so you'll see white salt down on the bottom if you boil off all the water. So you get it back again. And that's a physical change. All of changes in state are physical changes. And in this case, that would be a physical change as well. So you can separate that mixture with a physical change. Now, can you separate this mixture with a physical change? In other words, can you reach in and pull them out and pull them out and pull them out? Yeah. And so a heterogeneous mixture can also be separated by physical means. Like suppose you eat raisin bran in the morning for breakfast and you don't like raisins. You can, they keep their identity. The raisins are still raisins, so you can reach in there, you can pull all the raisins out and enjoy the bran. All right. So that is a heterogeneous mixture. This one that I just showed you and the raisin bran. Now, there are two types of heterogeneous mixtures. There is colloid and suspension. And a colloid can be exemplified by milk. And if you take a look here, I have some milk. Pretty good milk. Now, the reason we call it heterogeneous is because there are fat globules in there that are bigger and fat globules in there that are smaller and some that are medium sized. And so it's not consistent throughout. You might have bigger ones over on this side and then smaller ones over here. So no matter how hard you shake it, it's still not going to spread it out evenly. Secondly, it doesn't settle. If it settles, it would be a suspension, but it stays up. Milk stays up, and so it is a special type of heterogeneous mixture called a colloid. Now, if it's a colloid, you're going to get the Tyndall effect. So can you turn the page, please? And go on over to page 466. And do you see, no, 467 at the top. Do you see how light, when it goes through a solution, now you're going to have to look up there on the whiteboard. You see how the light went right through and it's on the whiteboard. However, when you shine the light through a colloid, it does not go through. It does not go through. Instead, it illuminates the colloid. Let's go ahead and go back to the solution. And you can see that it does not get stuck inside the solution. Look at that. Let's see here. Let's try to get something that I need 3 hands. Let's try to get something I can be shining it on. Okay. You see the A and W can goes right through and hits the A and W can. But with the colloid, it gets trapped inside because the colloid particles are so much bigger and it illuminates, it scatters the light. It's called the Tyndall effect. Say Tyndall effect. Okay, so colloids would be exemplified by milk. Now, have you ever been driving down the highway with someone else, of course, and you see a shaft of light going through and there's a fog outside? And the reason that we have a shaft of light scattering light with those particles of water called fog is a colloid. So fog's a colloid. And how about smoke? Do smoke particles, do they kind of stay up in the air? Yeah, so smoke goes up and it's a colloid. And what's a combination of a smoke and a fog? Of course, you know that's a smog. We have plenty of that over the big cities. Now, another colloid would be paint. Paint is a colloid. So fog, smoke, milk, paint, those are all colloids. Suspensions. Suspensions are a special type of heterogeneous mixture, and they settle out upon standing. Gravity has its way and pulls particles. So this is a heterogeneous mixture called orange juice, and I enjoy drinking this. And you can see it has to be stirred or shaken because I buy the kind that has pulp in it, because they say it's better for me. So there it is. If I let it set, it will settle down the pulp, and then I'll have to stir it or shake the bottle before I drink it. Now, what's going to happen when you shine a light through here? Yeah, it does get bright. And so it can show the Tyndall effect, which indicates that it's a heterogeneous mixture. And particularly the Tyndall effect applies to colloids, but in this case, it applies to a suspension. Sometimes suspensions are exemplified by muddy water. In that case, you don't see the light at all because it's kind of like it's opaque to light, and it just stops at the bottom. It doesn't even get into the muddy water because it's so thick with mud. Now, muddy waters form deltas. You know what a delta is? A delta is like the Mississippi River plunging into the Gulf of Mexico. So here's the Mississippi. As long as it's agitated, as long as it's flowing, it's going to remain suspended up in, the water. Here's all of that. And as soon as it hits the Gulf of Mexico, what happens is all that muddy water drops its dirt, the silt, the dirt, the mud, and it forms what's called the delta because the Greek symbol that looks like a triangle is called delta. And so this region down here near New Orleans, it's called the Delta region. Kind of a reclamation project for the dirt of Missouri that picks up in the Mississippi River. So river deltas are big examples of how particles in a suspension will settle down. Do you ever have oil and vinegar as a salad dressing? You have to shake it first. The reason is because they separate or they settle out, all the particulates settle out, and so you got to separate it to get it going again. Okay, those are called suspensions. Now, let's take a look at this flow chart on page 468. On 468, you're going to see matter at the top, and then mixtures and pure substances, but they have it reversed from what I have. But we study this typically from the idea of pure substances first, and then mixtures after that. So I don't like that chart on the top of 468. I wish somebody would have flipped it over for me, but it sure does summarize everything. Now, one thing that they tried to make clear to you is mixtures can be physically separated, their components, whether they be homogeneous mixtures like a solution, or whether they be heterogeneous mixture like a milk or like a orange juice or like a muddy thing. You can always separate it physically by filtering it out, by boiling off the water, by reaching in there and pulling it out. Some of these materials are magnetic, like iron filings or something, and you can take a magnet and pull them apart that way too. When I teach this subject in school, we actually have a lab on this and we pull apart mixtures, but not this time. Okay, that's great. You did a great job of listening. Thank you. Do the quiz.